Hello there. I just want to do a quick video on the Ciw Python package, and specifically today I want to cover load balancing. So the previous video, if you've been following this YouTube series, was on a phenomenon for or a mechanism of routing called join shortest queue, where when a customer leaves a node and goes to the next node, you have to decide which node they end up going to, or do they leave the system entirely. And join shortest queue says for whatever are a set of target destinations, send the customer to the node that has the shortest waiting list. Load balancing is a little bit more, wouldn't want to say it's generalized, but it is a slightly different target set of nodes in the sense that not that you change how you set the destinations, but rather that the rule of where you send them is slightly different. So join shortest queue is all about targeting the node that has the greatest number of waiters, but you could also think about joining the node that has, join shortest queue is joining the node that has the smallest waiting list. Load balancing is about joining the node that has the smallest number of customers in it, period. That's both the waiting area and those that are already being currently served. So it's a more of like a total population to the node and adding people to the node that has the minimum number of either waiters or in service. And those can have some mathematical consequences in terms of distributions. I just wanted to create as an example just to show how easy it is to use. It's essentially the same as the shortest queue, where you just need to specify in your routing object a routing network, and then among your routers, for whichever ones you want to have load balancing behavior, you need to specify for that node. So in other words, load balancing is not defined for how a node receives, but rather how it sends customers to other nodes. So in this case, if you're at the first node, as a customer, you'll go to either nodes 2, 3, or 4, and that will just depend on which ones have the least amount of customers in the entire of those nodes. Otherwise, if you're leaving from one of those other nodes, you leave the system entirely. So it's a simple enough example here. We've thrown a few other things in based on the docs, like we've got some processor sharing nodes and whatever, but really it's a very basic idea. So let's just run the example. And so this is the frequency distribution of the number in the according to different state probabilities of how many individuals were in the system at those times. And so here we see this distribution of, it looks like the majority of the time we had 0 customers in the system, and about a third of the time there was 1, 17% of the time there was 2, etc. So the point is not to study that distribution too much, but it's just to say, really, load balancing is the same idea as the join shortest queue, except that the priority rule is based on total node population, not the waiting list size of the nodes. Okay, so with that, hopefully that's useful in building your next discrete event simulation, and I'll catch you in the next one.